This video is going to be an intro to exponential functions, and we're going to start by figuring out how do you identify an exponential function. We look at a table, an equation, and a graph. So here's a table, and the reason why we know that this is an exponential function is you're looking at the pattern that happens from one f of x value to the next. So how do we get from 5 to 10? You could go plus 5, but then 10 plus 5 is not 20. So what's happening here instead is to get from 5 to 10, we're going times 2. To get from 10 to 20, we're going times 2, and that is the pattern. So when you have repeated multiplication of the same value, that's exponential. Now, this pattern only works if your x values are increasing by the same value each time. So notice our x values go 0, 1, 2, 3. So because of that pattern, we can use the times 2 as our pattern, and it's exponential. All right, how would we write the equation for this? So the equation for this, f of x is equal to, you start with what's your initial value? What is your f of x value when x equals 0? And that, in this case, is 5. Okay? And then next comes what your multiplier is. The number that we're multiplying by each time is 2. And this is exponential, and that gets written right there. So anytime you have an equation with a variable for your x as an exponent, that's how you know you have an exponential equation. All right, what does this look like when we graph it? So exponential numbers, they're numbers that go up really fast. So you can see my scale here, my y-axis or f of x axis is going up all the way up to 40. Each thing's worth 10, whereas my x-axis is only going up by 1. So if we just plot these points, we've got 0, 5, which would be about right there. 110 would be right there. 220, and then 340. So each time we go to the next value, it's doubling, and the doubling is happening because our multiplier is 2. So we can try to connect these with a nice smooth line. And that's what an exponential graph looks like. I've heard some people call it a J-curve. Mine doesn't really look like a J right there, but you get the idea. Let's go ahead and actually backtrack a moment here and compare the linear function versus an exponential function when you have a table. So first we have a linear function because our pattern here is plus 3, plus 3, plus 3. Okay? And for a linear function, that pattern, that's our m value, that's our slope. Okay? Again, this actually works as long as over here it's going plus 1, plus 1. If this was actually over here a different function, then that changes everything. All right, our b value is 2. That's whatever f of x is when x is 0. So with m and b, I can go ahead and write my equation. F of x equals 3x plus 2. All right, how about exponential? Exponential, we've got our IV is initial value, and multiplier is our other important thing. So let's look at our pattern here. Our pattern here is times 3, times 3, times 3. Okay? So times 3, that is our multiplier. And our initial value, our starting point when x is 0, is 2. All right? So if I'm going to write this one, I've got my initial value first, and then in parentheses I put my multiplier, and then I need my variable is going to be an exponent because this is exponential. Okay, so let's just do some quick connections here. Notice how these things line up. So you can see that there are some things that are the same, that are very similar between linear and, exponential, and some stuff that's kind of mixed around the other way. The last thing we're going to do in this video is go ahead and graph two exponential functions that might be a little different than what we've seen so far. So I'm going to graph these ones by just making a table and evaluating. So we know this first one would be 3 to the negative 2 minus 1. Then we have 3 to the negative 1 minus 1, 3 to the 0 minus 1, and you get the idea here. 3 to the 2 minus 1, and 3 to the 3 minus 1. So I could start at the top, where I'm going to end up with 3 to the negative third power, which we haven't talked about negative powers yet. Instead, I'm going to start at the bottom because I think this will be easier for me to figure out. So 3 minus 1 is 2. So this is just 3 squared. That's just 9. And then 2 minus 1, that's 3 to the first. And hopefully you know that anything to the first power is itself. All right? And then 1 minus 1 is 0. I'm just going to skip ahead to my answer. You should also know that anything to the 0 power is 1. All right? So then I need to come up with 3 to the negative 1 power. So what is that? What's going on here? Well, look at this pattern so far. To get from 1 to 3, I'm going times 3. 3 times 3 is 9. So when I'm going down my table, it's multiplying by 3. If I want to go the other direction and go up the table, I would do the opposite. I would divide by 3. So this will help us see what happens with negative values. So if I'm at my 1 here, at 1, 1, and I want to go to the value for 0, if I'm going to go backwards, 1 divided by 3 is 1/3. Okay? Let's see. Dividing by 3 is the same as multiplying by 1/3. So if I want to continue the pattern up to get my value for negative 1, that would be 1/3 times 1/3, or 1/9. And then this last one up here would be 1/27. Also, a thing that's going on here is this 1 to the negative 2 power. 1 to the 9th is 1 to the negative 2 power. That's 3 to the negative 2 power. That is 1 over 3 squared. My handwriting's terrible there. But that's another way that we can get these values that go negative. Just think backwards in the pattern if you weren't sure what to do with negative exponents. All right, let's go ahead and graph this. So I'm going to start with my 3, 9. Over 3 up 9 is right there. Then I got 2, 3. I've got 1, 1. And then I go to 0, 1/3. And then it just becomes closer and closer to this line, like I can draw 1/27. So when I connect these, I'll do the best I can. It kind of looks okay. Just realize that this part of the graph just gets closer and closer to 0 without ever getting there. Okay, let's do one last graph. And this time I'm going to see if I can think my way through it and maybe not have to write so much work. So I'm just going to use a table again, but I'm just going to start with my value at 0. So I know if I put this 0 in for x, if that's 0, anything to the 0 power is 1. So this whole thing would just become 1 times 16. That's 16. Notice that right there's our initial value. So it matches up what we're doing. And this 1/2 is our multiplier. So I'm technically just multiplying by 1/2. So half of 16 is 8. And then I would just continue to multiply by 1/2, which means the same thing as dividing by 2. So this would become 4. 4 divided by 2 is 2, and so on. I guess I'm going to add one more. 4 would be 2 divided by 2 is 1. Now going the other way, notice going down, look what's happening to these numbers. They're getting smaller. If I go up, it's going to be technically divide by 1/2, which is times 2. So right here would be 32. Right here would be 64. Those are not going on my graph. Actually, only 4 of these are going on my graph. So that's how you could attack this without just writing everything out and substituting it all in. So if I'm going to graph this, the first one that shows up on my graph would be 1, 8. And then I got 2, 4. And then I got 3, 2. And 4, 1. All right. And then these would just form, again, we get a J curve going down like that. I could do more points if I wanted to see what's happening over in this part. But you get the idea. That's a legitimate graph for what we had to graph. And that will conclude our intro to exponential functions.